All right. Good evening, Dr. Heyer. So I have my outline here, and so I have it, the evolution of non-mammalian synapsids to mammals, and this my outline starts with an introduction and sort of background information. And in this section, I kind of want to. All right, so to back up a little bit, how I designed this outline was basically because I was totally lost with this topic. And so I asked myself, well, what information do I need to know in order for it to make sense? And so that's how I wrote my paper, as if I was writing to myself to get understanding. And so the introduction and background, I want to discuss what tetrapoda is, and also I might totally mispronounce a lot of these names because it seems like a different language. And it's funny because I've had historical geology and paleontology, but I remember not liking it very much because, well, first of all, in paleontology we didn't do like vertebrates was like a super small portion of the whole thing, and then invertebrates was the whole, and I kind of just, my attention was not really there as far as all the just a lot of shells, anyways, I'm getting off topic. So I want to talk about tetrapoda in the intro and background, and I'm not going to go into a ton of detail, just very key things about tetrapoda, amniota, reptilia, and synapsida, right? So the difference, the distinguishing synapmorphies of those two groups. And then that's a good background to get into the pelycosaurs, right? Like the basal synapsida, the genera of the basal synapsida, and then the pelycosaurs, and then on to Therapsida, the Cynodontia, and Mammalia. So how I'm going to do that in my second portion after the intro is going to key transitional genera, where I'm going to pick a genera inside of those superclasses of Synapsida, Therapsida, etc. And so the genera I chose is Eothyrus, Tetraceratops, Trirazognathus, Morganocontids. And so each of these genera are representative of one of these superclasses. And after I give the key transitional genera and discuss those things, I'm going to take examples from each of those groups and discuss key synapmorphies. For example, in Synapsida, the broad, low or flat skulls and whatnot. In Therapsida, the Sider and Hobson, 1998, they found 48 possible synapmorphies within Therapsida that distinguish them. And then the Cynodontia, the expanded temporal fenestra, lower jaw modifications and stuff for what's inferred to be a more muscular, a more muscular like head. And then Mammalia, live birth, nursing with milk and whatnot. So, and then get into the conclusion where I cap, okay, this is what a tetrapod, an amnio, and then synapsid, and then from synapsid all the way through Therapsid, Cynodont, and Mammalia. And we discussed how do we know that these were the transitions in evolution because of these synapmorphies, and now we have mammals from all that. And so I think that would be thorough. I feel like I can probably even be more specific, because I feel like obviously people get PhDs in this sort of thing, so you theoretically could just continually write. And so I guess my challenge right now is kind of picking a lane and going down there. But right now, seems like very, very general and a lot of information. But anyways, that's what I have as far as an outline. And I printed out this phylogeny of from the article that you provided initially, because this was the key for my understanding. I took a bunch of notes, and then that really helped me as far as picking other articles and everything and understanding the articles. So anyways, that's where I'm at. That's what I have. This was a long-winded video, but I'll talk to you soon.